Welcome to the deep dive. Today, we're looking at something truly iconic, the Apollo moon landings.
Yeah, one of humanity's biggest leaps.
Absolutely. But, even decades later, there are still quite a few, let's say, persistent questions and myths floating around.
Yeah, really are.
So our mission today is to kind of cut through that noise. We're using solid sources to unpack some of the most common doubts and give you clear science-backed answers.
Exactly. We want to give you the facts
Yeah.
because honestly, understanding the science and the incredible engineering behind Apollo, it doesn't make it less amazing. It makes it more so.
Couldn't agree more. Okay, so let's dive in. First up, a real classic visual puzzle,
Hmm.
the American flag. In the photos, it looks like it's waving, but no air on the moon, right? So what gives?
That's a great starting point because it really gets at how different the lunar environment is. It looks like it's waving, but it's not wind.
Okay,
The flag was actually mounted on a pole with a horizontal bar along the top edge that was specifically to make it, extend outwards unfurled.
so it wouldn't just hang limp.
Precisely. And when the astronauts planted it, they twisted the pole into the ground, which caused the fabric to ripple and bunch up a bit.
Right, just the act of setting it up.
Exactly. And here's the crucial part. In the vacuum of space, there's no air resistance. Nothing to damp down those ripples. So that initial motion, those folds and wrinkles from being deployed, they just stayed there.
So it's like a frozen wave, almost. Created by the setup, not by wind.
You got it. A perfect illustration of inertia in a vacuum.
That makes a lot more sense.
Yeah.
Okay, sticking with the visuals, what about the stars? This one gets asked all the time. Why aren't there any stars in the pictures taken on the moon? Space is full of them.
Yeah, another really common and very understandable question. It boils down to photography basics, really. Exposure settings.
Exposure, how so?
Well, I'll think about how bright the lunar surface is when the sun's hitting it and the astronauts' white suits. It's incredibly bright.
Like a sunny day on snow, maybe?
Kind of, yeah, very high contrast. So the cameras had to be set with very fast shutter speeds and small apertures, short exposures to capture that bright foreground properly without washing everything out.
Okay.
Stars, even against a black sky, are comparatively very faint, just incredibly dim next to the sunlit moon. With those short exposure settings needed for the main subject, the faint light from the stars just didn't have enough time to register on the film.
So it's like trying to take a picture of stars during the daytime here on Earth. You wouldn't see them either.
Exactly the same principle. If they had used settings long enough to capture stars, the moon's surface and the astronauts would have been completely blown out, just pure white.
Right, priority was capturing the landing site, not the background stars.
Got it. Okay, let's shift to the hardware. The lunar module. Big rocket engine firing downwards to land. Shouldn't there be a massive blast crater underneath it?
You'd think so, wouldn't you? Especially comparing it to, say, a launch from Earth. But a couple of key things are different.
Like what? First, the descent engine wasn't firing at full blast when it landed. They throttled it down significantly, like way down for the final touchdown. It was designed for a gentle landing.
Okay, less power.
Less power, yes. And second, remember the gravity. The moon's gravity is only about 1/6 of Earth's,
Ah, right, less pull.
which means you need far, far less thrust to counteract it and set down gently. So while the exhaust did blow away some dust and maybe shifted a few small pebbles right underneath.
Like a kind of scouring
Perfect.
effect?
Exactly, a scour mark, not a deep crater.
Hmm.
The pressure from the exhaust hitting the surface was actually pretty low by that point. Not enough force to dig a big hole in that compacted lunar soil.
Low gravity and throttled engine.
Yeah.
That makes sense. And that low gravity environment also ties into this next point, which is just mind-blowing. The footprints, are they really still there, perfectly preserved?
It sounds incredible, doesn't it? But yes, they almost certainly are. And the reason is the moon's unique environment itself, or rather what it lacks. Meaning there's no wind, no rain, no atmosphere to speak of, none of the erosion processes that constantly wear things away here on Earth.
So nothing to wipe them away?
Nothing at all. A footprint, once made in that lunar dust, just stays for potentially millions of years. It's like a pristine, static archive. The only thing that could realistically disturb them is a direct hit from a micrometeorite, which is, pretty unlikely for any specific footprint.
Wow. Yes. Untouched history. So, okay, bringing this all together, how do we know for sure today, with modern tech, that the landings actually happened, beyond these explanations for the common doubts?
Right, because explaining doubts is one thing, but positive proof is another. And we have multiple, very strong lines of modern evidence. Three main ones stand out.
Okay, what are they?
First, the retroreflectors. These are special mirror rays the Apollo missions left behind at several landing sites.
Okay.
Yeah, laser-ranging retroreflectors. Scientists here on Earth regularly shoot powerful laser beams at them. The beams bounce back. And by measuring the round-trip travel time, we can calculate the Earth-Moon distance with incredible precision, like down to centimeters.
And we can only hit them because they're exactly where Apollo left them.
Precisely. Proof they're there. Second, we have high-resolution images from orbit.
Orbiting the moon now.
Yes, spacecraft like NASA's Lunar Reconnaissance Orbiter, LRO, it's taken detailed pictures of all the Apollo landing sites. You can literally see the descent stages of the lunar modules, the scientific equipment left behind, even the tracks made by the lunar rovers.
Wow. Actual photographic evidence from orbit.
Undeniable. And third, perhaps the most concrete evidence, the lunar rocks.
The samples they brought back.
Exactly. Nearly 400 kilograms of rocks and soil samples. These aren't just any rocks. They have unique isotopic signatures like different ratios of certain elements, high amounts of gases like helium-3 implanted by the solar wind, and specific mineral compositions.
Films that just don't match Earth rocks.
Not at all. They are unmistakably extraterrestrial and match the composition of the moon as we understand it from other measurements. You put all that together, the laser ranging, the orbital photos, the unique geology of the samples, it's just overwhelming, consistent physical evidence from multiple angles.
It really is. It paints such a clear picture. It's quite humbling when you think about the ingenuity, the sheer human effort involved, and how science clarifies these things that might seem mysterious at first glance.
It truly is. And you know, the story isn't over. The legacy of Apollo is directly influencing what's happening right now. We see nations like the US with the Artemis program, China, India. They're all pushing forward with new missions to the moon.
Building on that legacy.
Absolutely. Which leaves you with a thought, doesn't it? As we head back, aiming for perhaps longer stays, what new mysteries will those future footprints uncover? What new perspectives are waiting for us up there?